Taking a look at the linear systems, weekly review number 10. Remember, these are systems of equations, of linear equations, not of quadratic linear pairs, just linear equations. So when we're talking about that, what we're looking at are where these two lines intersect. So we're looking for just that one point of intersection, something like that. Let's use our substitution method that we've been using with all of our systems so far this week. And we know that y equals x plus 7. So I substitute that in for y, and now I get x plus 7 equals negative 2x plus 1. And from there you can solve for x, and then don't forget to go back and solve for y. The next one is not set up as a system that can be solved easily through substitution method, because if you notice, there are no variables that are isolated. X is not by itself, y is not by itself. You could solve it for x or y. So for example, I could take x plus 2y equals 12, and I could isolate x by subtracting, oops, I was supposed to subtract 2y, so let me erase that. I would subtract 2y from both sides, and then we know that x equals negative 2y plus 12, and I could substitute that in for x. The other thing you could do, I'm going to erase this for a second. The other thing you could do is use your elimination method. So we've got to think back to last year when we used to look for matches. And we looked for matches, we were looking for when we had the same variable, same coefficient, opposite signs. And when we didn't have that match, we could create a match. So here's what I mean. If I look at the y's, for example, I have the same variable, opposite signs, but one of them is 2y and one of them is 1y. I could create a match by multiplying the second equation by 2. The first equation didn't change. X plus 2y equals 12. The second equation now has been multiplied by 2, so I have 4x minus 2y equals 8. You'll notice here in the x's, or excuse me, the y's, that's a match. And when I say that that's a match, what that means is we could add these two equations together, and 2y plus negative 2y equals 0. So all I'm left with is x plus 4x, which is 5x, and 12 plus 8, which is 20. Then you could solve for x, and you could solve for y by substituting in x and getting the y value. And that will work for your elimination method. If you look at this next one, this is also set up for the elimination method. You could use substitution, but you'd have to isolate A or B, which I think would be a little less sufficient than just using the elimination method. But remember, we have to find a match. And in this case, we do not have one. We have 2A and 5A. We have negative 2B and negative 3B. Let's say that I want to create a match with the A's. I want them to have the same variable, which they do, the same coefficient and opposite signs. I could do that by multiplying both equations by each other, because then I would get 10a minus 10b equals 30, because I distributed the 5, and I would get 10a minus 6b equals 18, except I need them to be opposite signs, so I'm going to make one of them negative. And by doing that, now I have negative 10a, positive 6b equals negative 18. And once I get to there, I can add them together, and the a's eliminate. Negative 10b plus 6b is negative 4b equals, and then you would add 30 plus negative 18 and solve for b. I'll let you take it from there. Don't forget, once you have b by itself, you substitute it back into one of the two equations so you can solve for a. The last one, another system to solve for the point of intersection, and it wants you to solve it algebraically. And neither of these equations tell you what x equals or what y equals, so substitution could be done, but you'd have to rearrange one of them to solve for the variable. I again would use the elimination method here. Now, typically the elimination method, we have the equations stacked on top of one another, and in this case they aren't, but that's not a big deal. We can just rewrite it. 4x minus 2y equals 6, and 3x plus 2y equals 8. And notice here that you have a built-in match, which means you don't have to do any extra multiplying. You can just go ahead and add and solve for x. Don't forget to go back and solve for y.